Everyone, today we're going to talk about the remainder and factor theorems and how they help us with polynomial equations. So the first thing I want to talk to you about is the remainder theorem. The remainder theorem, think about when we say remainder, we are going all the way back to when we learned long division, and sometimes when we divided by something we got a remainder. That's the same remainder that we're talking about now. When using division to find the factors of a polynomial, the only important part of the answer is the remainder. Therefore, we need a quicker way to find the remainder. So I want us to think back to our previous chapter 4. And when I made y'all divide a polynomial. So for example, I made you divide 3x cubed minus 4x squared plus 2x minus 8 divided by x minus 2. And you had to do long division with that. And you got a remainder. And it took forever, but the remainder is important. Well, there are a couple of things I'm going to show you where we no longer have to do long division. Okay, so I want you to know that the remainder of p of x, which p of x stands for your polynomial. So that's your 3x cubed minus 4x squared plus 2x minus 8. That's your p of x. So the remainder of your polynomial equation divided by the factor x minus a. Remember what a factor is, right? A factor is what's being multiplied with other stuff to equal your equation, right? Is equal to P of A. And what that means is that you are going to plug in this A value into your equation, do the math, and whatever it's equal to, that is the remainder. That is the remainder. All right, so let's see what that looks like. Let's say we have x cubed minus 5x squared plus 7x plus 13 divided by x minus 4. So before, you would have to do long division and figure out what your answer was and figure out what the remainder is. Not anymore. You know that all you have to plug in is in your a value. Now remember, it's x minus a, and this is x minus 4, which means a is equal to 4. So we're going to plug 4 into this polynomial. We're going to plug in 4. And when we do, instead of writing x cubed, we write 4 cubed minus 5 times 4 squared plus 7 times 4 plus 13. And we end up with 57. Awesome. So that is our remainder. That's our remainder. Next question. What is the remainder of 3x to the 4th minus 4x cubed minus x squared plus 9x plus 2 divided by x minus 1? So instead of having to do long division, we are going to plug in our a value into the equation. And we know that our a comes from the x minus a. Since we have x minus 1, our a is 1. If that was x plus 1, our a would be negative 1. Okay, just want to make sure that you're understanding that. So we're going to plug in 1 into this equation. When we do, we get 3 times 1 to the 4th minus 4 times 1 to the 3rd minus 1 squared plus 9 times 1 plus 2. And we end up with the answer 9. So let's say they want us to find the remainder of this. X to the 5th, 6x squared minus 9 divided by x plus 2. I want you to go ahead and try this one on your own and see if you can get the answer. Go ahead and pause the video and try it out. All right, well, if you plugged in negative 2 for x, because remember, you are going to plug in your a value, and your a comes from the x minus a of the factor. This is not x minus a number. This is x plus a number, so it's the opposite. So you're going to plug in -2. So it'll be -2 to the 5th power plus 6 times -2 to the 2nd power minus 9. And when you do the math, you end up with -17 for your remainder. One more problem. X cubed minus 5x squared plus 7x plus 13 divided by x plus 1. Again, when we plug in a value to find a remainder, we're not going to plug in 1. We're going to plug in -1 because it's supposed to be in the form x minus a, and it's not. So in order for it to be in x minus a, it would be x minus -1, which means it's -1 for our a value. So we plug in -1 for x. And when we do that, -1 cubed minus 5, -1 squared plus 7 times -1 plus 13 is going to give us 0. And we get a remainder of 0. Ooh, if it's a remainder of 0, that means in long division, remember if there's no remainder, that means that went evenly into what we're dividing into, which means that x plus 1 divides evenly into x cubed minus 5x squared plus 7x plus 13, which means that x plus 1, since it had a remainder of 0, is a factor of this polynomial. Bringing us to the factor theorem. All right, so the binomial x minus a, again, remember this form, this is x minus a, x minus a. So if there's not the minus there, then you have to switch your a to be negative. The binomial x minus a is a factor of the polynomial p of x. So that's going to be your 3x squared plus 7x minus 2, if and only if, so the only way x minus a will be a factor is if the remainder of p of x divided by x minus a is 0. So that last problem that we just did, because our remainder was 0, that meant that what we divided by, that binomial, was a factor of that polynomial. You don't have to divide to decide if it's a factor. Just evaluate at a. So all those problems we just did, we didn't have to divide anything. We just plugged a into the value. We plugged a into the polynomial and see if we got 0. If we got 0, it was a factor. If we didn't get 0, then it wasn't a factor. So again, you don't have to divide anymore to decide if your binomial is a factor of the polynomial. All you have to do is evaluate the a value. All right, so let's test our skills. We want to know which of these binomials are factors of x to the 4th minus 10x cubed plus 17x squared plus 52x minus 60. So they give us, the first factor they give us is x minus 5. I'm sorry, the answer already showed up on there. It says good. So if we have the binomial x minus 5, before we would have to do x to the 4th minus 10x cubed plus 17x squared plus 52x minus 60 divided by x minus 5 and do long division and see if it worked. And if it divided evenly using long division, then it was a factor. But if we divided it and we got a remainder, then x minus 5 was not a factor. We don't have to do that anymore, okay? We now know that in order for x minus 5 to be a factor, we had to be able to evaluate our a value, which here the a value is 5, into our polynomial. And if we get 0, then the binomial is a factor. So 5 to the 4th power minus 10, 5 to the 3rd power plus 17 times 5 to the 2nd power plus 52 times 5 divided by 60. That got us to 0, which means that x minus 5 is good to be a factor. So next binomial we want to test is x minus 2, which means that we are going to plug in 2 into our polynomial. So 2 to the 4th minus 10 times 2 to the 3rd plus 17 times 2 to the second plus 52 times 2 minus 60. And we do not get 0. We do not get 0 when we plug those numbers in. And so, because we don't get 0, that means that x minus 2, that binomial, is not a factor of that polynomial. Next factor we want to test is x plus 2. So x plus 2, the a value for x plus 2 for that binomial is negative 2. Remember, because the theorem says that it has to be x minus a. So in order for our a value, in order for us to have that minus, our a value has to be negative. So we are going to test negative 2. Our a value is negative 2 for number 3. So we're going to do negative 2 to the 4th minus 10 times negative 2 to the 3rd plus 17 times negative 2 squared plus 52 times negative 2 minus 60. When we do that, we get 0 as our remainder, which means that the binomial x plus 2 is a factor of our polynomial. Okay, here's a question for you. Is x plus 1, which is a binomial, a factor of x cubed minus 7x squared plus 4x plus 12? Go ahead and pause the video, work it out, just evaluate the a value. You don't have to do long division, just evaluate your a value to see if it works. If you get 0 for your remainder, find the answer and then check it and unpause the video. All right, so you should have plugged in negative 1 into your polynomial because remember, we're looking for our a value and we get that from x minus a. And since we have an x plus, that means our a value is negative. So our a value is negative 1. So when we plug in negative 1 cubed minus 7 times negative 1 squared plus 4 times negative 1 plus 12, we get 0, which means that yes, x plus 1 is a factor. Now what about x minus 3? Is that a factor? So for this one, we're going to plug in 3, because 3 is our a value here, and we plug in 3 for our a value. I'm going to go ahead and let you try that. So go and try and see what you get and come back. All right, so you should have gotten something that was not 0, which means you got a remainder, which means that no, x minus 3 is not a factor. All right, so your goal is to factor higher order polynomials without having to use long division. We can determine if a binomial x minus a is a factor now. All we do is evaluate the a value. Okay, no more long division. Our question is, so far, we have been given x minus a. We've been given the binomials to check. But how do we choose which binomials to check? If they're not going to tell us test x minus 1, how do we know to test x minus 1? Well, there is something called the integral root theorem. And that says if p of x is a polynomial function with integer coefficients, remember coefficients comes before the variables, then any integral root is a factor of the constant term. So remember, the constant term is the term that does not have a variable. So we're saying that your roots have to be factors of the constant term. Have to be factors of the constant term. Here's a note. Most polynomials look like this. Don't be afraid. The subscripts that they're using are just used to label the term, right? They're just used to label the term. All right, another shortcut I want to teach you is synthetic division, okay? Which is a shortcut for dividing polynomials. the first thing you're going to do is change the sign of the divisor. You're going to write all the terms in descending order, leaving a 0 anytime an exponent is skipped. You're going to bring the first term down, multiply this by the divisor, and then add this to the next term. And then you write your answer. It's super fast and super easy. Let's go ahead and look at one. Let's say we have 3x cubed minus 4x squared plus 2x minus 8 divided by x minus 2. So first thing, change the sign. All right, so this is going to be 2. This is going to be 2. It's our a value. A value is 2. Okay, you write your terms in order. Okay, so we have a 3 for x cubed, so that goes there. We have a negative 4 in front of x squared, so negative 4 comes next. We have a 2 in front of x, so 2 comes next. And then we have negative 8 as our constant. All right, so bring down the first term, that's 3. Then you multiply that by what you're dividing by, so 2. So 2 times 3 is 6. Now you add going down. So negative 4 plus 6 is 2. Then you multiply. 2 times 2 is 4. Then you add going down. So 2 plus 4 is 6. Now you multiply. 2 times 6 is 12. Add going down. Negative 8 plus 12 is 4. So your answer now is going to be 3x squared. So if I started with 3x cubed, my answer is going to be 1 power lower. So if I started with a cubed, my answer is going to start with the squared. So I get 3, and that comes from this 3 here, 3x squared, plus 2x, and that 2 comes from this, plus 6, which comes from this, okay? Well, I just did plus 6, and 6 is my constant for my answer, which means that this number left over is my remainder. I have a remainder of 4. All right, let's try one more synthetic division problem. In this one, not all of our terms are represented. So we are dividing by x plus 3, which means my a value is negative 3. Notice that, a value is negative 3. So I have x to the 5th. That's my starting highest degree, which means my answer is going to be to the 4th, right? My answer will be to the 4th. But right now, let's list our coefficients. Our first coefficient is 4. Now I need the coefficient for x to the 4th. But x to the 4th is nowhere in our polynomial, which means that there's a 0 in front of it. So I'm going to write 0 for my coefficient for the x to the 4th term. Now for the x to the 3rd term, that coefficient is negative 35. So that's what I will write next. Okay? So I have the coefficient for x to the 3rd. Now I need the coefficient for x squared. But x squared isn't anywhere in my polynomial, which means there's a 0 in front of it. So for my coefficient for x squared, I'm going to write 0. And then my coefficient for x is 2, and then my constant is negative 7. Okay? Now I start my process. You always bring your first term down. So I get 4 for my answer. I multiply my answer by my a. So negative 3 times 4 is negative 12. And then I add to get a new answer. So 0 minus 12 is negative 12. I take my answer and I multiply it by a. So negative 3 times negative 12 is positive 36. And I add that to get my new answer. Negative 35 plus 36 is 1. I take my answer and I multiply it by my a. So negative 3 times 1 is negative 3. Then I add to get a new answer. 0 minus 3 is negative 3. Now I multiply. Negative 3 times negative 3 is 9. Then I add. 2 plus 9 is 11. Then I multiply. Negative 3 times 11 is negative 33. Then I add. Negative 7 minus 33 is negative 40. So my answer, again, we're going to drop a degree. So we're going to start with to the 4th degree. So we get 4x to the 4th. We get negative 12x cubed. we get 1x squared, or just x squared. We get negative 3x, or minus 3x, and then we get plus 11, which means our last numbers are a remainder. We've got a remainder of negative 40. So that says that this polynomial divided by x plus 3 is this with a remainder of negative 40. All right, so now that we have learned all of this new information, we're going to put it all together and talk about how we can use all of that to solve polynomials. So let's go quickly over the steps. Step 1, decide what binomials we want to check using the integral root theorem. So we're only going to check a values that are factors of our constant term. Remember, they have to be factors of that constant term. Number 2, we're going to use our remainder theorem and factor theorem to find a binomial that is a factor. So once we've gotten the factors of our constant, then we're going to test them by plugging them into our polynomial to see if they will work. Once we find one that works, we're going to use synthetic division to divide the polynomial by the factor. And when we use synthetic division, we can then finish factoring the solution because it'll be a quadratic. If it's not a quadratic, so if the degree is still larger than 2, we have to repeat the process again. And then step 5 is set each factor equal to 0 and solve for x. So let's look at our first one. X cubed minus 5x squared minus 17x plus 21 equals 0. So first we want our possible roots, and they had to be factors of our constant. And our constant is 21. So the factors of 21 are 1, 3, 7, and 21. And remember, this is positive and negative. So plus 1 or negative 1, plus 2 or negative 3, positive 7 or negative 7, plus 21, negative 21. So let's try 1 first. So we're going to plug in 1 into our equation. So 1 cubed minus 5, 1 squared minus 17 times 1 plus 21 equals 0. So yes, we found one already. 1 as an a value works, okay? So now let's use synthetic division. So 1 we know is a good a value. And our coefficients, we start with 1, that's in front of x cubed, negative 5, which is in front of x squared, negative 17, which is in front of x, and then 21, which is our constant. Bring down the first one. 1 times 1 is 1. Negative 5 plus 1 is negative 4. 1 times negative 4 is negative 4. Negative 17 minus 4 is negative 21. 1 times negative 21 is negative 21. 21 minus 21 is 0. Oh, we have a 0 remainder, which is what we were supposed to have because we already decided that 1 was an a value. We already said that 1 was an a value, so you should get 0 as a remainder, okay? Now we have a new equation to look at because we started with x cubed and when divided, we end up with x squared. So we have 1x squared, which I just wrote as x squared, minus 4x minus 21. Okay, that's a quadratic, so we can factor that. You can use the reverse box method, whatever method you want, but when you factor x squared minus 4x minus 21, you get x minus 7 times x plus 3. So the last step is to set everything equal to 0. Okay, so we already know that 1 is a solution. So we got x equals 1. X minus 7 is equal to 0 tells us that x equals 7 is a solution. And then x plus 3 set equal to 0 tells us that x is equal to, oh, that's a typo. This should be x equals negative 3 right there, correct? This should be x equals negative 3. Should be negative 3 right there. Let's look at one more problem. X cubed plus 2x squared minus 5x minus 6. First, get our possible factors, 1, 2, 3, and 6, positive and negative. So let's try 1, okay? It worked last time. So 1 cubed minus plus 2 times 1 squared minus 5 times 1 minus 6. Oh, that is equal to -8. So no, 1 is not a possible a value. Okay, let's try -1. Okay, so -1 cubed plus 2 times -1 squared minus 5 times -1 minus 6. It equals 0. Okay, so yes, -1 is an appropriate a value. That's one of our solutions for sure, is -1. So since we know that -1 will get us a remainder of 0, we're going to use synthetic division now. So we're going to use -1 as our a value. That was the a value that worked. We're going to write our leading coefficients, which are 1, 2, -5, and -6. Everything's represented. You bring down the first one, you end up with 1. -1 times 1 is -1. -2 times -1 is 1. And then 1 times -1 is -1. -5 minus 1 is -6. -1 times -6 is +6. And then -6 plus 6 is 0. So again, we got that remainder of 0. But that leaves us this simplified equation, which is, since we started with cubed, which means we go down to x squared. So we get 1x squared, which I just wrote as x squared, plus 1x, so I just wrote that as x, minus 6. And this is a quadratic, so that factors to x minus 2, x plus 3. You could have used the reverse box method if you want. And now we get our x values. We know that x equals -1 because that worked for us. Now we solve here, x is going to be 2 and x is going to be -3. All right, that's all there is to it. Thank you for tuning in, and I hope to see you soon.